Can I also?
My Monday is bleeding over into my Tuesday really bad, so you guys are just gonna have to bear with me for the next couple hours. So last time we talked about our financial sheets and like statement of cash flows, balance sheets, things like that. So we're gonna take what we learned last time and apply that when we talk in chapter 17. But we're gonna kind of divert just a little, loosely related, but we're going to talk about time value analysis. There's competencies agenda of what we're going to talk about today. So we're going to be talking about present value, future value. We're going to do a little around opportunity cost rate, talking about annuities and perpetuities, and then talking about amortization schedules, which everybody probably is familiar with the amortization schedules and doesn't even realize it yet. If you've ever had a car or a car payment, then you're familiar with amortization schedules, or how, if you've had a house and make a house payment, you're familiar with amortization schedules. And we'll end on that one with chapter 9, and then we'll jump over to chapter 17. So we'll talk about timelines and talk about, you hear people say a lot, time is money, right? So we know there's a certain dollar amount. Oh man, I hope the video comes up to play. There is a certain amount tied in terms of time, and let's see. Get that up. I'll pause that just 1 second. So TED Ed, if you've ever been in one of my classes, I love TED. I love TED Talks. I think they're just the best thing ever. So I use a lot of TED Talks in my lectures, and TED Talks has kind of this offshoot called TED Ed. And they have a lot of great talks I really highly recommend. They have short little videos, 3 to 5 minutes, on different topics. And there's this great one on time value of money, and it kind of sets up for what we're going to talk about today. So we'll watch this, and I'll post the link on D2L for the online folks, because I know like video kind of comes across weird through Tegrity. So we'll go ahead and watch this. Learn about time value of money, and then we'll jump back up to the slides. So let me pause it there first. So he asked the question, what does one really have to do with the other? So before we even get into this, what do you think one has to do with the other? What do you think time has to do with money, or how they affect each other? And if you don't know, that's fine, because that's what we're going to be talking about today.
The value of money change over time.
Yeah, the value of money is going to change over time. It's going to change with kind of the ebb and flow of the economic tides, and the different investment activities that we decide to undertake. So I was just curious to see kind of what kind of association you guys tied there. So these are the two concepts that we're going to be talking about today in terms of time value of money. So we're going to talk about we're going to talk about future value first of money, and what that means, and kind of how to solve and calculate for that, and then we'll kind of jump backwards and talk about present value of money. Does everybody see what they did there? So we wanna know what the future value of our money is gonna be in 2 years, right? So how we're gonna solve that is we're gonna take what we have now, the present value, $10,000. We're gonna multiply that by 1 plus our interest rate, I think was 10%, right? And then we're gonna raise that to the number of periods. So we're looking at 2 years. If we were looking at maybe 5 to 10 years, this would be 5, 6, 7, 8, 9, 10, whatever it may be. So, maybe a little elementary, but I think TED Talks does a good job of just kind of illustrating some different concepts that we're going to talk about in class and kind of breaking them down into short little videos that put a little bit of humor behind it. Maybe Timmy should have considered a different price card or something. So that's just a good setup for, like I said, what we're going to be talking about today, which is time value of money. So the first thing we're going to talk about is discounted cash flow analysis. And we know that anything that we have any monetary value that's tied to any assets that we have, whether that's real, like brick and mortar building, equipment type assets, or financial assets like our investments, our stocks, things like that, they're going to be based on future cash flows because we expect to earn some type of interest rate associated with that, right? Especially with our financial our financial assets. So based on, the short little video, what do you guys think? Is $1 received in the future? So if I give you $1 tomorrow, is it worth more tomorrow, the same, or less than if I gave you $1 today? What do you think? Less. Who says more? Does anybody say more? Does anybody say the same? Why is it less?
I don't know, for some reason over time when it just don't have the same value.
Well, it is less. And so, and the reason behind that is because if I give you $1 today, I can go to the bank, I can put it in, it can start earning interest today. But if I give you $1 tomorrow, we're already a day behind on earning interest. So a dollar or an amount down the road, a couple days out in the future, is worth less than if I were to give you $1 today, simply because of the investment factor. So what we typically work with for time value analysis, there's a couple ways to go about it. And I'm going to show you, I think I got 2 on here, doing manual longhand calculations through timelines. And then later on I'll show you some Excel nifty tricks and stuff to use. My recommendation is anytime Excel is an option available to you, use it because Excel is your friend, even though it's a little scary sometimes, especially if you don't use Excel a lot. But we'll go over the timeline first and kind of go over how the timeline's set up from the beginning and then get into how we use it to kind of solve time value analysis. So every time we have a tick mark, you see we have one at 0, 1, 2, 3, 4. This is going to notate the end of a period, right? So from here to here, we start at period 0. This is 1 year, 1 month, 1 week, 1 day, whatever our period setup is. From 1 to 2, right here's where we're going to end period 2, right? End period 3. So the tick marks are going to denote the ends of periods in our timelines. Like I have here, 0 is going to be our starting point or the beginning of period 1. So where we have period 1 ending, this is the start of period 2, end of period 2, beginning of period 3, so on, so on, so on. So if we go ahead and start jumping into a little bit of the math. If we wanna find the future value after 3 years or 3 periods of $100 that we invest at 10%, we're gonna do something called compounding. So when we compound, we move from left to right along the continuum. I thought I had a nifty little like arrow that moves along the bottom in there. So we move from left to right, starting with our initial investment. Now, can anybody go ahead and kind of hypothesize why that would be negative, the negative $100? Because it's a cash outlay, right? That's money we're taking out of our pocket to invest. So anytime you start, your cash outlay or your beginning amount is always going to start as a negative, just because it's an outlay out of your pocket. We're kind of putting that money up front before we start earning interest. You got to pay money to make money, or whatever that saying is.
Spend money.
You got to spend money to make money. Thank you. I'm telling you, Tuesday's been my Monday all over again. I've had 2 Mondays in a row now. It's not been fun. So for right now, as we kind of move through the next couple examples, we're going to assume that this is paid annually. So we can assume these are years, periods, not months or quarters. So when we solve for future value, we're going to go from today's value into the future, and we're going to solve that through this equation. So we're going to have the future value, denoted by FB, future value of whatever our sum is going to equal the present value multiplied by 1 plus the interest rate raised to the number of periods, just like they said in the video, right? So if you can, this is another one of those formulas. What was the one we were solving? The A equals L plus E. This is another one. If you can just remember this, if I give you any one of these numbers, you should be able to solve for the missing variable, right? Like if I give you future value, present value, and the number of periods, you should be able to solve for n just by moving a couple variables around and looking for that particular variable. So future value is going to equal present value times 1 plus the interest rate raised to the nth power, or the number of periods. So if we go back to our example, and we look at the future value of 3 years of a $100 lump sum invested at 10%, how would you start solving this? So this is where we're going to get interactive. We're going to do a little math. So how would you start to set this problem up? And I'm going to stand up here with my marker while you guys tell me. So we have future value, right? So what goes next?
The present value.
Which is
100.
100. Then what?
1 plus
10%.
0.10. How many periods?
3.
30. Right? So our formula should look like this. So we know 100 times 1.10, which is this right here, is going to equal 110. So if we're looking at 2 years, after 1 year, we're going to have $110. After 2 years, I was saying I better have it on there, we're going to have $121. So see, we just keep multiplying it on out. And then after 3 years, what do you think we're going to have? After 3 years.
133.
Ah, okay.
No,
Not sure what just happened. Okay. 133.10 is what we should have. Oh, sorry, were you guys trying to figure out? I'm sorry. I had technical difficulties. So we're just going to input, pretty basic equation, fill in our present value times 1 plus interest rate raised to the third. So we should get 133.10 is what our future value is going to be after we account for interest across 3 years. So in general, formula again, just trying to, keep reiterating it to you guys. If you can just kind of burn this formula into your brain, you'll be fine. Just remember, future value is going to equal present value times 1 plus the interest rate, and then depending on how many years you're solving for. So there's 3 methods that you can go about finding future value. And this is where I've said if Excel is available to you, I would use it because Excel is your friend. You can go about using a regular calculator, which you can kind of imagine can get a little convoluted. If I ask, okay, what is it at 20 years, 26, it's gonna get a little convoluted as we keep going on down. There is a financial calculator with financial functions, and that one will have this formula already built in. I don't use financial calculators in this class. You're welcome to go grab one and try it if you want. My primary method or my preferred method, if it's available to you, is to work with a spreadsheet like Excel. Simply because you can put all these formulas in, and I'll go over how to set those up. And Excel pretty much just does the math for you. So it's, you don't have to think about it, because you do in terms of how you set it up, but it's going to be a little less confusing than trying to use a regular calculator and getting the variables mixed up and everything. So the non-financial calculator solution, so just using a regular calculator, just doing the math like we just did, 100 times 1.1 raised to the third, or 1.1 times 1.1 times 1.1. But if we go over to a spreadsheet solution, we're going to set it up kind of like this. So if you always remember your number of periods on top, so we're going to fill that in with 3. Our present value goes next at $100. And then our rate, or interest rate, is going to be at 0.10. So how you set this up is you can tell Excel, to get $133, I want you to take what's in A3, the present value, times 1 plus whatever I have in A4, raised to the number of periods. And then that'll calculate out and give you a future value of 133.10. Like I said, it's all the same. You end up at the same end point. It's just about how you go about solving it. And, I just love Excel, and so I just use it all the time. But there's nothing wrong with one method over another. So let's say you inherited $10,000 at age 20.
Yes.
Right? Every 20-year-old's dream to have a big check for $10,000. And you make some wise decisions, and you invest it for 50 years until you're 70. So if you get 10% a year, how much should you have when you retire? So go ahead, let's set it up on our formula. So you guys tell me what to fill in. We're looking for future value, right?
Mm-hmm.
So what do I put in?
10,000.
10,000 times
1
1
plus 10.
10
50 years.
to the 50. So what should that give me?
Oh, this calculator doesn't do it.
Do you have Excel?
Yeah.
Excel, preferred method. So I'll give you guys just a second. I don't want to take anything away from this experience of solving for time value money, so I'll let you give you a few minutes to figure out how we kind of got to that conclusion. And I'll go back to the spreadsheet solution if you want to look at that. So if you'll just get in the habit of setting it up this way, anytime you're asked for future values, it's going to be really beneficial to you down the road, especially when you start looking at present value and calculating for that. So just get it in a habit of setting it up like this. You're going to do through the spreadsheet. And then go ahead and put your formulas in.
Me too.
Yeah.
So it's only to that.
Once I have my calculator.
And how'd you do the 50 power? For 50?
So what did you guys get to?
1,173,909.
172,000.
Yeah.
72? Yep.
No, 33, yeah, sorry. I thought you were correcting me.
No, that's fine. 1,173,909. So everybody's kind of on the same page with how we got to that number, right? Simple plug-in of the calculation. I know this kind of seems a little remedial, but it's important to kind of build these foundations for when we start moving along throughout the course. So what if we're looking for present value? What if we know that at the end of 3 years, we're gonna have $100, and that's how much we want at the end of this investing period. So how much do we need to invest at year 0 to get $100? And whereas before, when we were looking at future value, we call this compounding. Now we're discounting back. So before we kind of work through this, let me see what you guys come up with and walk me through how you would solve this based on our formula that we know.
100 equals
Okay, so Ashley says 100 equals
PV
PV,
times 1 plus 0.10 to the third.
okay,
And then you do parentheses first.
okay, okay,
And you divide the 100 by whatever the 1.1 and to the third power is. Right? I think.
300 accept 100 over.
okay, so we're gonna look for,
Is it 75?
we're saying 75
So you
to
divide,
end with,
that would be 1.33, right?
1.33,
I think, yeah, 331, and then, you divide that by 100.
100,
You divide the 100 by the 1.33, right?
you tell me.
Yes.
We're working through this together.
Yes.
Okay, so let's see. So present value of 100 due in 3 years if the interest rate is 10%. So we're gonna take future value divided by 1 plus the interest rate raised to the n. Or plus, yeah. Nope, you're fine. So it's really gonna set up like future value divided by 1.10 to the third.
75.
So
Yep.
75, yeah. So
75
was
and
gonna
some
ask
change.
about-
Yeah, 75 and some change. So you see how we just kind of work some math around, move the variables to reach present value and solving for that just by taking the future value, dividing that by 1 plus the interest rate raised to the number of periods. Again, you can, let's see. Yeah, so if you discount it back, I think I have that in there, maybe. So if you discount it back, you can divide like we did before with your normal calculator. And how I got to these, you can discount it 1 period at a time, right? And here's how you would solve that for, on your Excel spreadsheet if you choose to kind of do that method. Same setup. Remember I said if you can kind of burn this into your brain, it'll benefit you down the road. So same setup, and then we just kind of tweak how we put the formula in. Or, I didn't point this out before, Excel has, these nifty, like you can do equal sum, whatever. The present value and the future value equations are already set in there. So if you want to not even mess with doing all this in row 6, you can come down and set it up how I have it in row 9. I was just saying Excel already has the formulas in there, which is another reason I suggest using it. So you can do equals present value and tell it to take your interest rate, comma, your periods, and then your negative future value, right? Questions so far? Pretty straightforward, right? Okay. Just keep moving along. So what do you guys think opportunity cost is? I think this came out of the reading for today. So what's opportunity cost rate or opportunity cost?
Is it what it sounds like?
Usually, I'm glad you guys have picked up on the theme. Usually things are exactly what they sound like, right? I don't try to trick you guys or anything. So when we look at opportunity costs, we're going to look at the costs associated with alternate use of the same funds. So if I have $100 and I'm going to spend it on XYZ, well, what's my opportunity cost if I go spend it on ABC? We're just kind of looking at the alternatives here. And the discount rate is essentially what the opportunity cost rate is. What can I do alternatively with my investment at similar risk? Is it going to make me more money, less money? Am I going to put in more or less? So we're looking at opportunity cost rate through discount rate. But it doesn't depend on the source of funds. Thought I had one more there. So when we look at an example, you played the lottery and won $1 million and remembered that you just loved accounting and finance so much that you just want to give your Humboldt instructor 500,000 of that 1 million. Yeah. So now what are you going to do with the money? So of course, if you're a wise investor, you may choose to go invest it in the stock market, right? Try to get some return on your investment. And you're going to put it in XYZ management fund. You're going to forego the opportunity to invest it somewhere else. And so that's essentially what I'm saying when we're talking about opportunity cost rate. What is the opportunity that you're kind of foregoing by making this one decision? So what's your alternative look like? So let's say we have a bank that offers an account that's going to pay, we have an account that will pay $200 after 5 years on each $75 you invested. So the implied interest rate, so remember we're taking out this variable, right? We don't know what the interest rate is. Set it up the same way, 5 periods. Present value, we know it's 75 because we're saying we're investing $75, right, each time. And we know that our future value is going to come out to $200. So what interest rate is that giving us? Same calculation, Excel will do that for you, and trust me, it's going to be much, much easier. So when it comes time for your exams and stuff, I know that the exams are set up through Lockdown Browser, but if you wanted to have a separate spreadsheet set up beside you on another computer or something, you can use that for Excel. And if you don't have that option, let me know and we'll find an alternative for you. But by putting in the calculation through Excel, solving for the rate, taking what we have in A2, the periods, A3, the present value, and A4, the future value, we're going to come to an implied interest rate of 21.7. So we're saying that bank has to give us 21.7 interest rate to get us from $75 to $200 in 5 years, based on our investments. So assume that we earn 20% per year, or assume we earn 20% per year. I think that's what it said. How long would it take for our investment to double? So now we're looking at what? We've looked at present value, we've looked at future value, we've looked at interest rate, how to solve. Now what are we looking to solve? Right, we're looking to see how many periods it's going to take to double that investment, right? So we're wanting to know how long we have to keep our investment in to make it double. So you have all the information here. See, remember I said, I should be able to give you everything except one piece, and you should be able to solve for that missing, solve for the missing piece. So you have your interest rate 20%. We're investing $1. Our future value, we're trying to get to $2 or double. Again, why is present value negative?
You're investing in it.
Right, that's our cash outlay. That's what's coming out of our pockets. So it's going to take about almost 4 years to double that investment, based on the interest rate and our investing activities. Again, you can solve that through Excel just by putting in the formula equals NPER. If you just start typing it in, it's going to say like number of periods. I think you saw that. Like start typing in. Yeah. So, and if you're familiar with Excel, when you start typing in the formula, it's going to give you a descriptor box out from it. See how it's telling you where to put what in?
Yeah.
And it'll walk you through how to put the information in for the formula. And if you're running into issues with doing the calculations through Excel, just let me know. And I'll be happy to walk you through it or record a little video if a lot of the class is kind of coming into an issue with this, to kind of walk you through how I got to these different calculations. So any questions so far about timelines, whether it's future value, present value, how to solve for periods, how to solve for interest rates? Like I said, I know this is kind of basic and elementary, but we're just trying to build the foundation to understand a couple concepts that we're going to talk about here in just a minute. Okay. Like I said, I know it's a lot of information, so if you walk out and forget something, just stop by the office and we'll chat about accounting and finance. So annuities and perpetuities. Annuity is gonna be your equal payments that are fixed at intervals for a number of periods. So you're gonna have X amount due every month, let's say if you have a card. You're gonna have a fixed amount that's gonna be due every month at the same time, right? Payments, often in Excel, or, I'll do this throughout the course too, I'll abbreviate to PMT, can either occur at the beginning of the cycle period or at the end of the cycle period. So payments, an example of that is, okay, my cable bill is due at the beginning of every period, right? I pay in advance for the service that I'm gonna use for the month. So that would be an example of a payment coming at the beginning of a period. And then you also have payments due at the end of the period, which can be like your credit card balance, it comes to the end of the period, you make the payment on the balance. So I have two types of annuities. The first one, because like everything else in finance, everything has about 5 or 6 different names attached to it. The first one's gonna be either called an ordinary or a deferred annuity. So if you see ordinary or deferred, know that they're the same thing. And one that we don't use too often is called an annuity due. So an ordinary or a deferred annuity is made at the end of each period. And an annuity due occurs at the beginning of each period. So which one would you think that we use most often? Ordinary, right? So since we use ordinary more often, that's what you're going to come into contact with more often. That's where we're going to focus our attention, just for purposes of the class. We have a limited amount of time to talk about a lot of material. So know that annuity dues are out there. I'm not going to expect you to know how to calculate them. I think the book goes over that. I'm not going to expect you to know how to calculate annuities due. But we are going to talk about ordinary annuities because they are the most common, and that's kind of where we're going to focus our attention. So solve some math for me. We have the future value of a 3-year ordinary annuity at $100 invested at 10%. Based on what we've talked about so far, what do you think that payment would be? At 1 year, so what we're going to solve is for 1 year, and we're going to solve for 2 years to get our total payment. And I know we haven't kind of went over the formula yet. I'm just trying to see how you guys are kind of piecing together the information that we went over so far.
It would just be 100 times 0.10, right, for each year?
Mm-hmm.
Okay. So 110 after the first year.
110. But we're discounting back, so we've moved back 2 periods, right? So now we're at 121.
Yeah.
We know our initial was 100, so we're going to be at 331 for our future value, right? Do you see how I got
Yeah.
to there? Just because we discounted back 2 periods, we discounted back 1 period here, right? And if we were moving forward, it would be the kind of the opposite. We would compound for 1 period and then compound for 2 periods. So again, every time I show you how to do it on the timeline, I'm going to show you how to do it on Excel as well. So this one simply, you know the formula. We're looking for the future value. You know the formula, we just have to work out the math. When we know that we're making a fixed payment at 10%, we're adding that percentage on each period. So we're making the $100 payment, but what we have to understand and recognize is there's going to be an interest rate that we have to pay associated with that, right? Just like your student loans, if you have loans, your interest is building over time. And if you don't pay off the full balance, it's going to kind of fluctuate based on what your interest rate is. So 331, because we have $110 discounted at period 2, and then $121 discounted at period 1. So we look to solve this on the spreadsheet solution. Same setup, notice the common theme. But this time we're looking at number of periods. So we know we know future value 3 years, $100, 10%. So So we know 3 periods, $100 payment, 10% interest rate, right? Now we're solving for future value. And it comes up to the same amount, so you can do it longhand this way, or you can do it this way through Excel if you have that option available to you. You simply put in future value. So we're saying, hey, take this interest rate and tell me what the future value is gonna be if I pay you $100 for 3 years. Right? Pretty straightforward, I think. If anybody's getting confused, just like throw something at me or.
It's still only remember the back.
Yeah, just remember when we're discounting back, yeah. So, when we work this one, what do you think? What do you think our solution's gonna look like? So we know our interest rate, right? We know our number of periods. We know our payments. We know we're solving for present value instead of future value, which is what we solved for in this one. So we're going forward. Now we're working backwards.
Something about this contract.
Yeah, we're just kind of moving it around, right? So we're gonna take 90, 91, because present value, we take the initial investment, the future value, right? And divide that by 1 plus the interest rate. And we're gonna solve for each period. So here's 2 periods, here's 3 periods. We're gonna get 3 different amounts, add them together, and that's gonna be our present value of the annuity. Does that make sense? Yeah? Okay. And again, like I said, I'll always show you the spreadsheet solution as well. So same setup, exactly the same as what we did last time, but now we're saying, okay, solve for the present value instead of the future value and put your information in the same way. Like I said, when you start putting this, let me bring up Excel so that our online people can see it too. If you guys will give me 1 second, get it brought up. That way you can see what I'm talking about when I say that it'll start giving you the information. Let me copy this down real quick. 300%. Okay, so if I'm saying, we said 3 periods, right? $100, because it's a cash outlay, right? And then 10%. So when I start saying, hey, I need you to solve for present value, so it's going to tell you what it's looking for. So returns the present value of an investment. When I start with my parentheses, put the information in. See how it's saying, okay, first you need to put your rate in. So I know I need to go get my rate, 10%. And then I need to put my little comma, because we don't want to confuse it. Now, I need you to put your periods in. So go up, grab your period, put your other comma, and now I need to grab my payment, right? And then hit enter, and it's just like magic. So Excel, and so if we want to do future value too, it's going to give you the same thing, rate. Oops, select the right one first. Rate, periods. This won't come out right because I have a negative in there, but it'll still solve for the same thing, right? Oh yeah, it did. So you see how Excel can kind of walk you through how to put those calculations in.
Were you the one that put the negative on the 100?
Mm-hmm.
Okay.
Yeah. So that's the only thing if you're
I know
doing.
that it's what you keep out.
Yeah, so that's the only thing. If you're doing it like this, you have to either remember to put the negative here, or you have to remember to put it in your formula. So if I didn't have the negative here in front of 100, I'll show you how it changes. So see how it's taking it negative? So if you don't want to put the negative up here with the 100, you can always go into the formula. See, that's A2, and you can put the negative in front of the cell.
Okay.
And it'll change it back over, right? I just think sometimes it's easier to maybe just go ahead and do it initially instead
I
of.
was just curious.
Yeah. Yeah. I guess it would help if I brought the PowerPoint back up, right? Okay, so we're still on track with annuities so far. And we can see kind of how the timeline and setting that foundation is tying into going through the timeline. So perpetuities, different than annuities. What is a perpetuity? How long does a perpetuity last? If you hold something in perpetuity, what does that mean?
Sure.
No?
Doesn't even look at for the annuity.
As English word. What
So-
is perpetuity?
So a perpetuity is a form of an annuity, but it's gonna last forever and ever. It's gonna be held in perpetuity. It's gonna go on and on and on and on and on forever. So how do we start to solve for the present value of a perpetuity? Now this is just a little bit different than what we talked about in terms of the timeline with solving for annuities. So when we look for perpetuities, we're looking for the present value of the perpetuity is going to equal the payment divided by the interest rate. So how do we solve the future value of a perpetuity if we know that it's an annuity that lasts forever and ever and ever? How do we solve that future value? So dramatic changes can occur in the interest rate. As the I increases, we can automatically assume the perpetuity is going to be equal to less. And conversely, if it decreases, it's going to be worth more because we're having to pay less interest rate on our payment. But because it's held in perpetuity, it's a little more difficult to solve for future value. So when we talk about perpetuities, just know this formula right here on how to solve for the present value of perpetuity, because we can't really solve for the future value of perpetuity. Simply because, it lasts forever. How do we know? We don't. So we're moving along a little faster, just to make sure everybody's kind of on track. This is kind of really basic and simple, just learning where to plug the information in, and just a chance for me to show you on Excel kind of how to set this stuff up, because it can be a little difficult if you just try to sit down and do this yourself, and lots of aggravation and maybe throwing your computer and cursing at your instructor. And so just a chance for me to show you too kind of how to set it up on Excel, and anytime I can be a proponent of Excel, I take the chance. So next we'll talk about uneven cash flows. So uneven, or sometimes it's called non-constant cash flows, we're going to consider those the most important time value analysis in healthcare. And why would that be? I'll give you the answer. So we think about healthcare, think about utilization rates. So we know we're going to utilize services different from month to month. So it's going to be uneven, right?
Yeah.
So there's going to be variation in utilization. So think about, we're not going to use the CT scanner the same amount of times in March that maybe we did in April or in February. Same with like all of our other different scans or services. So we know there's going to be an uneven amount coming in across a year or across a period. So instead of payments or lump sum, which is what we were just talking about, more lump sum payments, uneven cash flows is going to use something called the CF, or the cash flow. And we're going to go over how to kind of set up solving for present value of uneven cash flow. So what we have here, we went back to our timeline, right? We have our uneven cash flow set up, 100, 300, 300, negative 50. So before we kind of get into solving, before I give you the answer, just let's do a little outside the box thinking. What would you think the formula for solving for present value is? How would you go about solving it? So we know the formula for present value, right?
So it'd be whatever year you're at, or whatever you're.
Yeah, it's still gonna be division. Right. So we're gonna do, that's not right. That should be these numbers right here. Sorry, that's an oversight. So we're gonna have 90, same way that we saw for lump sum. Yeah,
It's the same, because you have the same information, basically.
yeah, we just have uneven cash flows now. Instead of having 100, 100, 100, 100, we're gonna have 100, 300, 350. And like I said, these are oversights here. I just forgot to go in and change them. So when we solve for this, we call this the net present value, or the NPV. So just be aware that if you see NPV, this is what the NPV is, the net present value, uneven cash flows. So we take, we discount back for each period, add them together, and this is going to give us our present value. Good? Again, calculator or Excel spreadsheet setup. This is why it's important to know that this is the MPV, because this is the formula you're gonna have to put in when we're talking about it, if you wanna use Excel and use the formula function. So set it up with interest rate. And now, before, remember how we were just having one number that you had as present value or future value as payment? Now we have the uneven cash flow, so we have to set it up cash flow year 1, cash flow year 2, 3, 4. So we're gonna take the net present value of A2, which is our interest rate, and we're gonna say we want the net present value of these 4 years of uneven cash flows, and we'll get to $530.09. That makes sense. Sometimes this is where I start losing the class. I try to be very conscious that we're all on the same page, because it's a lot of math. I know it is. So if we have future value of uneven cash flows, sorry, I thought I had my little arrows. So we're going to compound forward, right? We were discounting before. We're going to compound forward. Same thing. Set up our formula. Solve for one period at a time. Add them up. We're going to have $935.63 by the end of year 5. Same setup as when we were solving for future values at the beginning of class. The only difference here is now we have an uneven cash flow, so we have to solve per period. And again, you can set that up in Excel the same way, and use your MPV function. Good so far? We'll get through this one and take a break, because this one's pretty short anyway. Oh man, thought I had that to pop up so I could quiz you guys. But what is an ROI? Hopefully everybody's familiar with ROI. It's a return on investment. So it's the financial performance of your investment package or your investment stock or your investment activity that's going to be measured by its what? The return, right? Pretty simple, like I said. Everything's pretty much what it seems. I don't try to trick you guys or anything. So we're going to use time value analysis to kind of calculate out these returns. And we're going to measure them either in dollar terms or rate of return or percentage. So a dollar return, just looking at this, it's going to be the effectiveness of this particular method of looking at dollar returns is that we're going to discount the process, and through that we're going to recognize the opportunity cost of capital. So what do we say opportunity cost is? What's that?
No, so I'm thinking about it.
Oh.
It was like the other,
It's forever ago.
no, it's like the other possibility.
Right, the alternative. What else could we have done with this investment? So I make sure to note, probably for some future quiz and or exam, that an NPV, a net present value of 0, is going to mean that our project, our return on investment, our dollar return, just earns its opportunity cost rate. And a positive NPV is going to indicate that the project has a positive financial value, so we're getting some kind of return on our investment after we consider the opportunity cost, or after we consider our initial investment into the project. So I make sure to note those two. So when we look at rate of return, so now we're going from dollar return to rate of return or percentage. The book pointed out that rate of return or percentage is going to answer one basic question. Does anybody know what that question is? So what interest rate has to be earned on an investment outlay to get our expected cash flow? So if we have this cash that we're going to invest, how much rate do we have to get on it to get our return back plus some? And we also call this our internal rate of return. So when we look at our internal rate of return, we're going to be solving for the interest rate. And this is another area where I would suggest not using your basic calculator. If you are familiar with a financial calculator, by all means use it. I would recommend using a spreadsheet to start solving for your internal rate of return. Because if you try to use a basic calculator for this one, where it's kind of easier before when we were talking about time value analysis, we start talking about your IRR, your internal rate of return. You're gonna have to do a lot of trial and error, so you're gonna spend a lot of time that you really don't need to trying to solve these equations out. So since I'm partial to Excel, we're gonna go over the Excel function on solving for internal rate of return. I just love it because it has all the functions already built in for you. All you have to do is remember to type IRR and set your stuff up, and it will do the work for you. So we have an internal rate of return. We have an interest rate of 8%. We have our initial outlay at year 1 or year 0 for the cash flow at $1,500. So we're putting $1,500 in. Year 1 at 310, year 2 at 400, 3 at 500, and year 4 at $750. So again, let me see if I can bring this up, because I think it'll do the same thing when I write this out. 300, 500, 750. Okay. Make sure I get all the information in. Okay, so if I set this up at 8%, and then I have my negative 1,500, then I have my cash flows. Oop. And then I'm going to say I want the IRR, returns the internal rate of return for a series of cash flows. I was touching it up here on my computer like you guys could see where my finger is pointing up here. Start our equation. So what's the first thing it's asking us for? Values, right? Here's our values. So we're going to take A3 through 7. And then we're going to put in our interest rate, which is just our guess at this time, right? Put that in. We're going to have an internal rate of return of 10%. So let me show you how that correlates with what we're talking about right now. But everybody understand this calculation, how to put that in? Right, see, don't you love Excel? I just love it. It does all the work for
I'm just
you.
gonna go invest and do all for that.
So we know that this is, again, is negative because we have that cash outlay. That's the initial amount we're putting in. Move that little annoying box up there. So we're going to get 10%. So kind of what does that even mean? So we have an IRR of 10, but what is that going to tell us as managers out in healthcare, or, if you don't go into healthcare, but from a managerial standpoint, kind of what is that IRR of 10% going to tell us? It's going to tell us that the expected rate of return that we're going to get back on the project is actually going to exceed the opportunity cost rate. So what we mean there, our internal rate of return, where did we get this number? This 8.
The cost? Or no?
Right.
Oh, right.
Our rate, our interest rate is 8%. That's our opportunity cost, right, is 8%. So we're going to have 2 percentage points more. It's going to exceed our opportunity cost rate by 2 percentage points because our internal rate is going to come back at 10% when our initial opportunity cost was 8%. So our expected rate of return is going to be higher than available alternatives of investment on similar risk to what we're going to be taking on with this particular project or investment. And then I have kind of like a little disclaimer down here, just about being important to note our increase in cost of capital. So if we're looking at what we may consider like ordinary investments, an increase in our cost of capital or our opportunity cost will not necessarily cause a decrease in any equipment or the project's IRR. I'll put that on there just as a reminder for maybe a future quiz or exam that you have coming up. That might be important if you'll just kind of burn that sentence into your brain and remember that. And that's about all I expect you to know in terms of cost of capital and opportunity cost rate. Oh, do I have that slide on there twice? Oh, that's weird. Okay. That just shows you how important I thought it was, I guess. So the last thing we're going to end with is amortization. Like I said, this particular lecture for chapter 9 is relatively short. because we have a lot to talk about through chapter 17. So what are amortized loans? And if you have a car that you make a payment on, a house that you make a payment on, you've seen an amortized loan because you make an amortized loan payment through those different capital purchases that you've made. So, sorry.
Go on. I was gonna say it's kind of like the value that the real value of the thing that you get when you calculate the price that you paid for it versus the price that it's valued.
Kind of, yeah. So what we're looking at in terms of an amortized loan is we're taking a loan out that's going to be repaid in equal amounts for a defined set of periods. So car loans may be paid every month, house payments may be paid every month. You may have loan payments that are paid every 2 months or 3 months or every quarter. It just is all how it's set up. But some examples, like I said, cars, mortgages, business debts, these are all amortized loans. So the life expectancy of an amortized loan is eventually going to come to an end at some point in time, right? So we're going to take out the car. What do you normally take out a car loan for? 60 months or something, 5 years. House loans are usually taken out on a 30-year basis. And then business debts, they're just kind of all over the place. But an amortized loan is one that is going to come to an end. It's going to be killed off, is what the book calls it. It's going to be killed off or paid off over a certain amount of predetermined time. So, like I said, car loan year, usually 5 years is what the standard is. Mortgages can range from like 15 to 30 years. So if we have Parker Health System, and they're going to borrow $1,000 from Pine Bark Bank, and they are agreeing to pay Pine Bark Bank back on, I don't think I could have made that any more like tongue twisting, Pine Bark Bank. We're going to repay this loan back in 3 equal installments, and the bank's going to receive a 10% annual rate on this outstanding balance at the end of each year, right? So whatever balance is there, the bank is earning money. That's why banks do loans, right? They don't do it just kind of out of the goodness of their heart, but they give you the money expecting you to pay a little extra back so they can earn money on that. So Parker Health System comes to you and says, we need to make an amortization schedule. So how do we start going about doing this? I'm going to show you how to set up the amortization schedule. Now this is one that you will see on your exam, so just kind of, if you have any questions on how to set it up, just let me know and we can discuss it. So what do we, where's my marker? Put it back in my pocket, yeah. So the facts that we know is they're going to borrow $1,000, right? What else do we know? The
3 years.
The Emperor is going to equal 3 years, and we have a 10%, right? So PHS is borrowing $2,000. Future value or present value? Present value, why?
Just say no now.
Right, that's the amount they took out now, right? And we're wanting to see how much they're gonna owe at the end of 3 years, right? PHS can repay the loan over 3 years, and they have a 10% interest rate on the outstanding balance. So we have all of our information down. Now what do we do with it? So the first thing we have to do is see what our monthly or our period payment's gonna be on that loan, right? And so since we said it's present value, how do you think we would start to calculate what our payment's gonna be? The trick is, trust me, Excel is going to be your friend for this. It was kind of a trick question. Sorry.
It's the same thing that we've been.
But yeah, but what we want to do now, we're solving for payment, where before we were solving for present value. So it was my little cruel joke just to see kind of what you guys would say. But trust me here, this is going to be a lot easier and a lot less convoluted. If you can just get in the habit of using Excel a lot for a lot of the financial stuff that we're going to be doing, it's going to make your life so much easier. So how we're going to set this up similar to how we've been setting everything else up, we're gonna have our interest rate up here, 10%, number of periods at 3, and our present value at 1,000. So before, where we were maybe solving for future value here, down here at the bottom, now we're gonna be solving for payment. So let me, this is another one I'll pull up on Excel to show you guys and our online folks. Let me write the information down. Okay, 10%, 3 periods, $1,000, right? So we're solving for payment, PMT, calculates the payment for a loan based on constant payment. Start our parentheses. What's the first thing it's telling me that I need to go grab?
Your rate.
Our rate. Then what's it telling me I need to grab?
The number of the period, number of periods.
The periods. And then what?
Present value.
Now, is this positive or negative?
Negative,
Negative.
Why?
because you're
They're giving it to already.
Right, it's the outlay. Yeah, it's the cash outlay. So since I didn't make it negative up here, I'm gonna put my negative sign in. I'm gonna cross my fingers and hope it works.
Well, it gave you the correct answer when you used it over there.
Yeah.
So,
So by putting it in that formula, we get $402.11, which I think is what shows up here. Yep. So you guys can see how we started to calculate. So this is the payment amount that we're going to make every period, right? So this is the first kind of component that we have to solve when we start setting up our amortization schedule. So $402.11 is going to be our payment. Then what do we do with it? So now we need to find out what our interest charge is on year 1 and our repayment of principal on year 1. So our interest charge is going to be our beginning balance, $1,000, right? That's what our loan started out with. We're going to multiply that by the interest rate. So we're paying another $100, right, on top of the loan that we took out. Then we need to kind of differentiate these two out. So we know that our payment is $402.11 total. That's our payment every month, right? But what we're trying to differentiate is how much of that is going to the principal. So when you make if you've ever had any kind of loan, you have a principal payment and an interest payment, right? So now we need to determine how much is going to principal and how much is going to interest. Well, we know how much is going to interest, $100. So we're just simply going to do some simple subtraction. Subtract that $100 off, $302. I promise that's a 2. $302.11 is what's going to be our principal payment, and then our interest payment. So we're kind of moving along. We're at step 3 right now. We've got our total payment. We've differentiated out what our principal and what our interest is. So the next step is going to be finding the ending balance at the end of year 1. So we said this is for year 2 through 3 years. So ending balance, we're going to take $1,000. We're going to take our beginning balance right at the beginning of the year. We're going to subtract from that our principal payment, $2.
Mm-hmm.
We're going to get $697.89. So we're going to complete this. This is the formula that we're going to follow along throughout the remainder of the life of the loan. So how you're going to set this up and how this is going to look is you're going to have your beginning balance of $1,000. We already know this. We know our repayment amount of $402. I have no idea why I didn't put $402.11. Who knows why I do half the things I do. So we have our payment amount of $402. Our interest payment of $100, which will leave our principal payment at $302. So why are we reporting $697.89, $698 instead of subtracting the total amount?
Our 690 is what is going on to the beginning of the balance for next year.
Right, and we're concerned with what we're paying back on the principal to see when we pay back the $1,000, right? So Ashley's right, this 698, the ending balance is gonna become the beginning balance the next term. And we're just gonna keep following it over. So we know our payment stays constant at 402, but look how our interest rate has changed. Why did our interest rate change? Because now we've got a new beginning balance that we're basing that 10% interest rate off of. So now we're paying $70 toward interest, and this is the same way when you think about how you pay back a car or a house loan, right? We start out with a really high payment towards our interest and a little towards our principal payment, and then over time that dynamic shifts because the balance is coming down. So we have interest payment at $70. We subtract 70 from 402, we're gonna get 332 now going towards our principal. So you can see how that principal is starting to go up over time as the interest rate starts to go down. We're gonna get 366. Moves that over, 366. Payment's still at 402, but now we have a new interest rate, a new principal payment because we have a new beginning balance. So the ending balance is gonna equal 0. And how you can kind of gut check is this should always equal 0 at the end of your life loan, right? Your ending balance. Your principal payment is always going to equal what your beginning balance is. So if you add up this column, it should always equal what your first beginning balance is. And then we can see how much interest we paid out over that life of the loan. So that loan cost us $206 on the outlay. So annual interest rate declines over time while your principal payment increases, which is good for us because that means we can pay the life of the loan off a little bit quicker. Save ourselves some interest. Does that make sense, guys? How to set that up? So I just, and like I said, I just try to be kind of hyper vigilant to make sure that it does make sense because this is going to show up on your exam. It's going to go beyond 3 years. It's going to be a little bit more complicated than this, but if you can get this basic principle down, then I should be able to give you a loan for 50 years and you should be able to figure it out. It's just a matter of, yeah, it's the same mechanism over time. Just, do your gut checks, make sure this column, the principal payment is always going to equal what the beginning balance was, kind of how that works over time. Okay, so before I let you guys go for a break for just a second, we're going to get back to our normal flow of things. So what are a couple things that we picked up on today to kind of do this self-building study guide? Yeah, the amortization schedule and how to construct it. What else? Annuity and perpetuities. What's that?
Rate of return.
Rate of return. IRR. Okay.
Opportunity cost, right?
What's that? Yeah, opportunity cost.
Future.
Yeah. Future value, present value, and the formula, right, for each FOR, ULA. It's a good list. I think that's pretty much everything.
NPV, can I understand what the,
Oh, yeah, MPV.
Yeah.
It's a good one. Okay.
and how it relates to the rate of return?
Yep, and its relation up to the rate of return. Okay, guys, when we come back, I'll have a little kind of test our knowledge from what we did from chapter 9, just so you get a little bit more practice in, because, the more we can practice things, the better and more comfortable we feel at it. So let's take, you guys want 10 minutes? Will that be enough? I'll give me time to run down to my office, too. So we'll take a 10-minute break and come back. I have 20 after right now, so let's just meet back at 2:30.